MakeCode. You're watching here for the Snowman army, which is what we're going to build today. This one is running in MakeCode for Minecraft 10. We're going to be Minecraft. So I'm going to stop this guy. And let's see, be sure I close this window. And now, before we get too far gone, I'm going to give you the links so that you can download the code. You're probably not going to want to follow along, although you might, because I'm going to be going a little fast. Can't help it. That's how I am. So, okay. I've been working on various versions of Snowman Army for more than a year, and I've become very intrigued that it's a really good teaching tool for learning about quite a number of different MakeCode things. And this program is probably more for intermediate MakeCode programmers, although brave beginners could also handle it, particularly since you're going to have the code and you can look at this video later and pause it and so on. The video is available for 2 weeks on Mixer, and then it will be on my YouTube channel. So to get started, let's create a new world. We want it to be creative, we want it to be flat, and we want it to show coordinates because that's sometimes very useful, and we want it to always be day, and then we want to play. I have a really beautiful, flat, peaceful world. Now, when I build things, I like to know which way is east, because when I express coordinates in MakeCode to help me visualize what's going to happen when I build something, I need to be facing east. So we are going to make us a compass. We're not going to learn about this compass today, but I did give you the code. So, whoops. There's something unique about this compass. In the code, there's one compass called compass, and there's another one called a compass. And a compass is really, really, really fast. Here we go. Now, watch it go. So basically, it's writing all of these things almost at the same time, which, as you know, if you've been programming MakeCode, the print function is really slow. So I usually lose patience if I'm going to print more than 5 or 6 characters, and I use a method called asynchronous, which someday we will learn about. But for the meantime, now we have a compass. So let's go back over here to code. And now we're going to get us a brand new program. And let's call this our Snowman Army. Okay. Oh, let me do something before we start this. Okay, let's look at what we're going to be building. Okay, this is the Snowman Army that we're going to try to build today. If we don't get finished, you have the code, and we will finish it next Wednesday. Pretty sure I can get finished if I keep moving along. Now, this looks kind of complicated, but the cool thing about coding is you can start building this one thing at a time. And we're going to build one module at a time, and each module or function, we call them in MakeCode, we're going to test it right after we build it. And that is one of the secrets to building strong software without making yourself crazy. Let's go back to our code. And when I am going to build something, and there's several things that I need. First, I really don't want the agent around. So I'm going to have the agent go away because I don't want him in my face for this program. Sometimes I want him to help me, but not this time. We're going to move the agent behind me. See, I think of my self as facing east, and this coordinate is the east if it's positive and west if it's negative. So I'm moving the agent 200 blocks behind me, and because I'm going to build out, meaning build to the east, which is a positive number, I'm not going to run into this guy. So so when on start runs, which is every time I hit the green button, it's going to move the agent 200 blocks behind me. Another thing I need, I'm sure you probably know that rain melts snowmen, which can be a nuisance when you're trying to make a snowman army. So the settings for MakeCode for Minecraft doesn't have the ability to cause it to always have the weather be clear. So, or at least I haven't found it. So what I do is I make myself a little forever loop. I put clear there, and truthfully, that's all I would have to do. But it just bugs me to be so inefficient. So I put a pause there, and I like to pause it about a minute. It could probably be 10 minutes. I don't know how often it turns on, the Minecraft turns on rain, but at any rate, when the way this runs is it runs forever. It starts, it clears the weather, then it pauses 60 seconds. During that time it's paused, it runs whatever else needs running, but then it interrupts whatever else is running every 60 seconds to clear the weather, which is, you'll never know that it took the time to do that. The next thing that I nearly always need, because when I test one of the parts of the program, I mess up my world because I build stuff. Maybe it was good stuff, maybe it was bad, but I need to move to a clean place in the world in order to try again or add something else to the program. So I always create a thing called Move Me. And what Move Me does is pretty simple. It teleports me to 200 blocks ahead. Now, as it turns out, I need to call Move Me sometimes from code. And I don't want to call the chat command. And there's a reason for that, because chat commands launch immediately and then the program goes on to running other things. So it might be that before I got moved, I did something else. I know that's confusing. Someday we'll discuss asynchronous. So what I do is I go make myself a function, and I call it Move Me because there's no conflict between the chat command names and the and function names. And what I'm going to put this in the Move Me function, and then I'm just going to call the Move Me function from there. So now if I'm needing to move me in the code, then it will run this function, and it will run it to completion, and I will have moved 200 blocks ahead before it executes any other code. Now, let's make a snowman. That's what we're here for after all. So let's do a chat command. I'm going to make this a snowman. And to make a snowman, you have 2 ice blocks, one over the other. 2 snow blocks, sorry. And so there's one, and I'm going to put it 2 blocks in front of me, and this one will be on the same level as the player's feet. Look at that. Is it raining? Yeah, let it have enough time to start raining. Let's go ahead and finish the snow. Okay. Then I have another snow block, and I want this one to be above the first one. So this middle coordinate is how tall it is. 0 is the level of my feet. 1 is above that. And then I need a pumpkin. And that makes a snowman. I see. Sorry. I think we can do better than this. How's that? Okay. And we need this one to be level 2. That should make a snowman. So let's go test snowman. Watch, you see it stop raining? Cool. There's our snowman. Yay. I'm going to call this first snowman because I want to make another one later. Okay, we made a snowman. Now, let's make another snowman. So I'm going to move me to a clean place. And now, ooh, I don't have a compass. What am I going to do? Oh no. Which way is east? Because I want to watch when that snowman does his thing. Okay. Oh, I know what we'll do. We will plant a sunflower. So let's make a function. So, whoops, that wasn't what I wanted. The sole purpose of this function is to plant a sunflower. And we want to know where it will be planted. So we'll have this position as a parameter. And I guess I could build up and then I wouldn't have to drag these down. Okay, sunflower. And in order to plant a sunflower, I need a block of grass, maybe, depending on where I want to put the sunflower. Sometimes I put it on top of my fence, so I have to have a block of grass. And the grass will be at position. Then the sunflower will be not at position, but it's going to be right above position. So we're going to add something to the position coordinates. And we're going to add some numbers. And it would work if you just put the numbers in this, I mean, the squiggly, the relative coordinates. But for reasons I won't go into, I prefer put them in the world coordinates because I do think of those as just being numbers. And Grandma gets confused if I think that it's relative and I'm adding that to something. And okay, that's enough of that. So we have a sunflower. Now we need a chat command for our sunflower to test it and to use it. And all we do is we call our function and we need a position. So we're going to have the position be the player world position. And we're going to add 1. So it's 1 block in front of me. We have to say -1 because we want the grass to be underneath the sunflower. And then, because we want the grass to be 1 under the player world position because that would be even with the other grass that's there. Okay, I'm already not happy with this. Okay. You're going to get tired of me doing that, but I'm going to do it anyway. 1, -1, and -1. So what that is the sunflower will be 1 block in front of me. It will be at the same level I am, and it will be 1 block to my left. And since it's to my left, it won't get in the way of anything I'm building because I'm always going to build to the east and south so that both of my X and Y Z coordinates will be positive and I don't have to worry about those pesky negative numbers. Okay, let's see if we got a sunflower. There it is. Now the cool thing about sunflowers, they always face east. So I don't even need a compass. I just need a trusty sunflower to follow me around. Okay, so let's go back to so now we could build another snowman and we could build another snowman if that one would get out of the way. And we could build another one and another one and another one. In order to build an army, we need a whole bunch of snowmen. So, got to be a better way than doing it manually. There nearly always is with computers. So, we're going to build some little code that will generate as many snowmen as you want. And we have to do this in a couple of steps. First, we're going to make a function. See, up here we built the snowman in a chat command. What we want is a function that makes a snowman. And we'll call it one snowman. And we're going to give it a parameter of, okay, where do you want the snowman? So that's a position variable. So it tells us where to build the snowman. Okay, so we want one snowman. And so you know how to build a snowman. You need to place the ice. But we don't want them to be relative to the player, which is what this code does. We want them to be relative to where. So that means the first block of ice will be right there at where. The second block will be something that looks like that. And this will be where, not player world position. And it will be just above that. So it will be 0 here, 0 here, and 1 there. So it's just above the first block. Then we need a pumpkin, which also is going to, whose position is going to be specified by something like this, and it will be 0 to 0. So it's just above the ice. So now all we need is, we need a chat command to call it. Now, where, I'm going to call this SM, where, for snowman, where do I want to build it? Well, I want to build it at something I'm going to call the origin for right now. And I always have a function called setOrigin. In fact, usually I just build it up front. Origin is, I think that's the 0 point between the X and the Z axis. You know all about origins. So I set the origin, and all that does is we create an origin variable, and we set it to we're going to set it to not exactly where the player is standing, because I'm here to tell you, you should never build where you are standing, because that has effects that I have explored a lot, and someday I'll do a little program on why you shouldn't build while you're where you're standing, and I can demonstrate lots of reasons why. Okay, we're going to go to ground. We're going to make the origin at 2 in front of me. So I'll be positioned so that I can watch whatever's being built, because I'll be behind whatever's being built if I make that the origin. So down here, when I'm trying to build this wonderful snowman, we're going to first of all call setOrigin. Then we have a variable that we can say put it origin. So this should build a snowman 1 place in front, 2 places in front of me. So let's go here. There. There's a snowman. Yay! And of course we could build another snowman. another one, and another one, and another one. But still, we don't have a good way of building an army. Now we get into the fun stuff. Sometimes you have to do little routines like this, which, whoops, what did I do? Nothing, I guess. Which can seem like they go on forever. You have to build up from the bottom, and then eventually you get to a place where you can do something very powerful. And we are there. We're going to call this random snowmen. And it's going to have a parameter that we're going to call in snowmen. That tells it how many to build. Wow, cool. Now, in snowmen, I'm going to make another variable here. And I'm going to set it to, basically we need to check this parameter some way. So what if it's negative? What if it's 0? You don't want it to be 0 because you wouldn't build any snowman. If it's negative, truthfully, I don't know what would happen. So we need to either check it and give a message. We could do that with an if statement and da 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 da. But there's an easy way. So what I do is I use a max function. Max and 1. So this in snowmen, there. So this means in snowmen now will never be less than 1 because it's the max. If it's -1, then it would be 1. So it defaults to 1. And you can do that all in less code than an if statement. Now we're going to call set origin. So always need a reference point. And then we're going to have some fun. We're going to have a repeat loop. This one works very well. And how many times is it going to repeat? You know, in snowmen. There it goes. Whoops, sorry, wrong place. What are you doing, Portia? In snowmen. Okay, wrong one. Thank you for telling me that. In snowmen. Okay, now comes the really fun thing. We're going to make a variable called random position. So this is, we're going to calculate a position where we want the snowmen built. And then we're going to call one snowman with that position. Is that cool or what? So now we have to get a random snowman. Don't know why it's giving me that. Oh, it's saying they mismatch, and they do because this is a 0, not a position, because I haven't picked it yet, haven't calculated it yet. We're going to pick a random position. Now, where do we want the random position to be? Well, we want it to be from origin, somewhere between origin and, whoops, that's not what I want, origin plus let's go make it 10 and 10. So basically a rectangle that's from the origin, the 0, 0 point, to 10 by 10, 10x, 10y, 10z, I'm sorry. And they're always going to be on the ground. So now what I think is we could make any number of snowmen that we want. If we did this correctly. Okay, let's just try. We'll try gently at first. Try 3. 1, 2, 3. Cool. Yay, yay. I just love it when something works. Okay, now that we know it worked for 3, would it work for 100? Oh my gosh. Would it work for 1,000? And the answer to that is yes. We might not want to wait and see all of them, but let's just try 30. Oops. I get so excited. Sometimes I'm just beside myself when I see this code doing Now see, you would never want to do 30 of these by hand. You would like totally make yourself crazy. But look at that, I'm beginning to have an army. Now, what's wrong with this army? Doesn't look like any army I've ever seen. It's like wandering all over. I thought armies, kind of came in rows and columns. So this one is almost an army, but not quite. So let's make an army. Guess what? I'm going to start with a function, and this function is going to make an army. Oops. And the army is going to have a position parameter, and I'm going to call it the army northwest corner. Now, think about what the northwest corner is. So if I'm standing at an origin place, then south is to my right, east is to my forward of me. So the northwest corner is the origin. So we're going to always build out from the northwest corner. So I'm going to specify army's northwest corner position, and that's where we're going to build it from. Okay, so now we have a really cool way. We could just put a loop in here, or double loops in order to build the army into nice square rows and columns. The trouble with that is that the first one Snowman you put in starts wandering around as soon as you put him there, and it takes pretty long time to create as many as you would want for an army. So by the time you get rows and columns created, they don't look like rows and columns anymore. So I found another way of doing it. We're going to use the fill statement, which is kind of like a double loop of rows and columns, but I won't bore you with that. Okay, Snowman, snow. Get us some snow, and then we're going to have a pumpkin. Well, let's do the pumpkin next. Okay, the snow is going to be from the northwest corner, of course, because we're building from there, to a calculated position, which is the northwest corner, plus 2 points forward, 1 point up, which means that 2 blocks will be in there, and 9 points to the right, to my right. So now I've got a whole block of snow that's 2 blocks high. Now what we want is we need a pumpkin, and we want it to be from the northwest corner, but we want it to be 2. Okay, sorry, this one needs to go here. It's from the northwest corner, but it's at position 2, which means it's above the snow. And then it's going to go 2, 2, 9, 2. So it's not, this stays the same because we only want the pumpkin to be 1 high. Okay, we got an army function. I think we ought to test it. So chat command. We have to set the origin. You have to call army, and we don't want it to be right at the origin, so we will do that, and it will be origin plus so it'd be 3 in front and 5 to the right. Now I can test army. Well, let's do it. Still got my sunflower. I'm facing east. There it is. See how, yay, yay, yay. You see how fast that happened? I love that. faster than a loop. It's very cool. Sorry, I get pretty excited when I'm coding. These are eureka moments. Now, what's next? We've got an army. So now I want you to see this army. Look at that. They're everywhere. They're just everywhere. I want to keep my little war, or I call it a match, contained. So I would like to have a fence. Now, fences can be a pain to build. I once started a program to try to figure out every possible way you could build a fence. Brute force, builder, agent. There's about 10 ways to do brute force. And then I happened on a way to do it that I thought was so clever that just from then on, that's the way I build fences. So I'm going to show it to you. So we want a fence, and we want it to have a position, and it's going to be the fence northwest corner. You're probably not too surprised by that. And I know by now you know what it means. Fence northwest corner. Well, here's what we're going to do. We're going to fill. This looks like a strange way to build a fence, right? I'm going to have an orange fence in honor of the pumpkins. And when I want a color of something, I just use concrete because it's very convenient. And it's going to start from, guess what? The northwest corner. And it's going to go to the northwest corner plus, I want this fence to be 20 by 20. So it's going to be 19 here, 19 here, and it's going to be 1 here because we want it to be 2 blocks high. Some of the mobs can get out of a fence that's only 1 block high. Okay, now let's run this to see what it does. So we need a chat command. We're getting pretty good at making these chat commands, aren't we? We're going to call this one fence. Isn't that clever? We need to call set origin. Get used to that, right? And then we're going to call fence. And we will just start the fence at origin. Why not? Then effectively that makes these fence northwest positions all be kind of relative to origin. So you could draw this out, which I've done many times, and place these things in a drawing so that you kind of know what you're doing. But I assume you're so advanced, you already know what you're doing. Let's run this. Well, I got something. Doesn't look like any fence I've ever seen. Okay, let's do something. Let's try fixing that. Well, we're going to fix it by carving out the middle. Isn't that cool? So we built the whole fence in one thing, except now we have to carve out the middle. So we just need some air. And the air is going to be, we want the air to be, not start at the corner. We want it to start at 1 and over 1. And we want it to only go 1. You know what? I did this one I did wrong because I don't want 2. That's a 3 high fence. We don't need that. We only need it 1. 2 high, which would be for 0 and 1 positions. Gee, I hardly ever make a mistake. Oh, my nose is growing. My nose is growing. Okay, we're going to fill it with air, and it's going to be 18, and 1. Now, notice that it's 1 because this starts at 0, and then 0y, and we go up to 1, and that's all we need. And it's 1 inside all the things of the fence. Let's try this again. Let's go move me. Now, that almost worked, but doesn't go down as far as I wanted. So what do I need to do? That needs to be 0, of course, the level of the fence. That's called debugging, and this is why you test each module at a time to be sure it does what you want it to do. There it is. We got a fence. Yay! Okay, now we have a snowman army. We have a fence. All we need is an enemy. Let's make an enemy. Well, we don't really want to make enemies, but we want to create some monsters in an army formation that can fight with the snowman. So first we will make a function, and guess what we're going to call it? Enemy. And it's going to have its first variable be a position variable, and it's going to be the enemy northwest corner. And I bet that didn't surprise you at all. Then we're going to have another variable, which is a number. And this is going to be the monster index. And that's because we're going to create an array of monsters that we can pick an enemy from. And so this will be an index into that array that chooses the monster we're going to fight. So we're going to get an array and we're going to make a list. Now monsters they're identified in Minecraft just by a number. So you can use an array of numbers to store monsters. Isn't that fun? Now we're going to rename this something very clever, like monster list. And then we're going to first put we're going to have 6 of these. The first one will be a shulker, which is one of my favorites. So we're going to get a mob, we're going to get our monster, and we're going to get this guy, the shulker. And the next one we want to be evoker. And then we want vindicator. Okay, come on. This sometimes does truly, there. Okay, makes me crazy. So now we want vindicator, there. Now those are the 3 monsters that are in MakeCode for Minecraft Education Edition. All the other monsters are available in Windows 10 version. And so I run my programs in both. So the next monster I like is zombie pigmen. I'm just enthralled with zombie. They do a really good job against anything. And so after that, I want witches because they are another. I'm always forgetting where witches are. There. They do. Witches are unique in that once they've killed all their enemy, they fight each other. So that's kind of fun to watch. And the last one, you can never leave out, you know who this is, Creeper, because he likes to blow things up. So that's a grand finale. Now we can't use a fill command to create these enemy rows and columns like we want to. So we have to use the famous double loops. So there's one loop, and there's another loop. Now, you would never want your 2 loops to have the same index, because that's a very big source of programming errors. So what we want to do is I like to create I's and J's. My I's are always the rows, and my J's are always the columns, because I can't remember very many things because I'm 77 years old. So we're going to make this one the I, that will be the rows, and we're going to make this one the J's. And in that loop, those loops, whoops, that's not what I was going to do. Thank you. And I'm going to put 2 here, because that's the number of rows we want, and I'm going to put 9 here, because we want 3 rows and we want 10 columns. That's what that gets you. Now we're going to spawn. I love spawning. Okay, spawn something. What are we going to spawn? Well, we want to spawn one of these guys up here. So we go to arrays and we pick out, get a value from our monster list, and we want it to be monster index. So let's see if I can pull it down. Yep. Now, where do we want to put it? That's the really cool part. We want to put it in this, starting with, guess what? The enemy northwest corner. And we're going to go to world I dummy me. I'm getting a little nervous because my time is running out, but I think I'm going to make it. I and J. Okay, that's where it's going to go. So now we need a chat command, simple little chat command to test this. So we're going to call this the enemy. I bet you can predict what I do. Guess what's next? Guess what's next? We got to set the origin, otherwise no telling where we'll be building. Then we're going to call army, call enemy, and the position we want is, remember this is going to be the northwest corner, so that's going to be origin plus $15, so I want it to be 15 away from origin and 5 to here. So that's where we want the enemy's northwest corner to be 15 from the fence forward and 5 to the right from the fence. And then the enemy index can be whatever we want. What do we want? Well, I think we want a parameter here called, what do you want to call it? What do you want to call it? How about enemy index? And we bring that down here. There, enemy index. Think that'll work? Let's go try it. Nothing quite like trying it. Well, I might. Okay, let's just see what happens if we try building it here. Enemy, let's try 0. That's the Schlurkers. There's one of them. Okay, so we got a little bug. Look at that. Look at that. It says index here. Oh, I drug them down here. Dummy me. Okay. You can't. If it's the word index, if it's the default, you can drag them. But if it's the, if you rename the index, you can't drag it. So I do this about at least once a week. Okay, let's try that again. We'll just do the same place. Now, I like using Schlurker. See it built from the corner that's closest to where we're standing. That's the northwest corner. And then it gives 3 rows and 10 columns. Cool. So we basically are at the point that we could have a war or a match. I call them matches. So let's create a match. A match is going to be a function. And it's going to have a number, which is the mob index. We're going to tell it which monster we want to fight. And then from there on, boy, is this easy. So we call move me, because we don't want to do it in this place we just did it in. Then we set the origin. See, once you get your functions built, you can just move right along. Then let's put a sunflower because, gee, I like to know where I am. And then we're going to build a fence to contain those little gadgets. And then we're going to build an army. And then we need an enemy. Now, all we have to do is fill these things in. So, moving right along, I want this one to be, I want a sunflower at, I should breathe. I forget to breathe when I get nervous. Okay, deadlines, okay. We'll do it at 1, -1, and -1. Gee, I thought I built a function that already did that. Anyway, we'll see what I'm going to do. Fence, we're just going to start the fence at the origin, so that's really easy. Then we're going to have the army be at 3 and 5. Whoops. And it will be 0 here. Then we want the enemy to be at origin plus 15 and 5. So they'll be lined up. See, 0. And then we have to tell it which enemy we want. So let's do shirkers again. The reason I like to test with shirkers is that they don't wander around. They stay in one place, so you can tell if your rows and columns are correct. So now we have to have a chat command to test it. And we need an index. And we need to call match. And we're going to call match with this. Whoops, you can't drag that. Okay. But I tried. Mob index. Okay, let's see what happens. Nothing like a little test. So look at that! Look at that! Yay! Yay! I'm so happy when things go right. Okay, that's very fun. There's one more thing I want to do, and I'm hoping we have time to do it, because it's an automated test script, and it is so cool. I think I can build it in 5 minutes, so maybe 7 minutes. So we're going to build it right in a chat command, which is kind of appropriate for a script, we call it. And we're going to have one parameter which tells it the number of mobs, and this means do we want to use 3 or 6 depending on which version of Minecraft you're using. And then we want to test. I'm going to set in mobs to another way to get my parameters in the bounds that I want. I want the minimum of the maximum. I'm going to leave you to count this out on your fingers and toes and be sure that I've done this correctly. And this would be in mobs inside here. And this would be 1, which is the least I want it. Whoops. Actually, that should be 0 because a shirker. No, 1. I'm sorry, these aren't indices. They're actually the number of mobs I want to test. And then 6 would be the most. Then I want to create a variable called bstop. I usually do my binaries like that because it helps Let me remember what they are. So, and I want B stop to start off false. And when B stop gets set to true, and I'll just show you how that happens, then this whole script will stop. So I'm going to have a chat command called stop, and in it I'm going to set this to, guess what, true. Now we're going to have a while loop. And it's going to be while the B stop is not, so it's while B stop is false. We're going to do some things. We're going to run we're going to note another loop in there. And it's going to have an index. And it's going to go from 0 to in mods. -1, and we know why that is. It's because arrays always start at 1, so the endpoint is not the number of mobs, it's the number of mobs minus 1. Now all we do is call match with the index this. Oh, look, I can copy that down. See there? Now, if I just ran it this way, it would run so fast you could hardly see it. So I'm going to put a pause in. Right there, so that it will pause 10 seconds between things. Okay, so now let's try this. Let's test. We're in Education Edition, so we're going to test 3. Now, this is a testing script. It's going to run through all my cases to be sure they're working right. So, no, I don't have my hands on anything. See, here's my hands. Here's my hands. It's supposed to do the next one. Now it's doing the next one. So you did the movie and everything. But look at that. It did slurkers again. So I'm thinking I have that's exactly what a test script is supposed to do. It's supposed to find the problems. And we have slurkers again. So what did I do? Call match with index. Gee, I hate to leave. I think I've got 3 minutes. I should be able to do this. Match. So that's the index. And then down here we're going to call the enemy. Look at that. I hard-coded 0. So what we need is this right there. That's a bug. And that's what a test script is meant to find. Let's do it one more time. And this time we have 3. There's the slurkers. In Windows 10 Minecraft, the slurkers can levitate the snowmen. In fact, all 3 of the monsters in here have slightly different Minecraft. Here's the evokers. They love to shoot out those tombstones. Here comes the old vindicators. And so now it's just going to keep on going. Whoops. Is this another bug? Maybe not. I think maybe it ran one more. So now it went around, and now it's going to, I think there might have been a bug. And I think we don't have time to wait for it, so I'm going to stop it. So I'm going to stop when it gets back to slurkers, because it's fast at the top. So when it would do slurkers again, it will actually stop instead of doing that. Okay. It is now stopped. Wow. And I'm Grandma, and we built the Snowman army, and we learned a lot about coordinates and positions and functions and modular testing and even a test script. So now you should apply for a job as a programmer somewhere. Cool. Bye.